Welcome to The Explainer. Today, we're going to dig into a question that's so common you probably don't even think to ask it. It's about the color of, well, pretty much the entire natural world.
Okay, so think about this for a second. It's a total paradox, right? Plants are basically solar-powered machines. They run on light, but they're green, which means they're reflecting away the very color of light that our sun pumps out the most of. It feels completely backwards. So why isn't the whole world just black, to absorb every last drop of energy? Believe it or not, scientists have been obsessed with this question for more than 200 years. From the moment they gave chlorophyll its name way back in 1817, all the way to finally building the molecule from scratch in 1960, it's been this slow, unfolding mystery. And all that work has led to three really compelling theories. Let's dive into the first one.
So our first theory completely flips the script. It suggests that being green isn't about being wasteful at all. Actually, it's a super clever strategy for survival.
Imagine trying to take a sip of water from a fire hose. That's kind of what a plant is up against. The sun's energy is so incredibly intense that absorbing all of it wouldn't be a feast. It'd be a complete overload. It would basically fry the plant's internal circuits. I love this quote from a science fan on Reddit because it just nails it. Survival is always a stronger driver in evolution than pure efficiency. I mean, think about it. A plant that runs at 100% capacity for one day and then dies is an evolutionary failure. But one that chugs along at 80% and lives to see another sunrise, that's a winner.
So the bottom line here is that too much sun is just flat out dangerous. It can literally cook a plant's cells, breaking apart the delicate little enzyme machines it needs to function. It also creates these nasty, toxic molecules and forces the plant to waste a ton of precious water just trying to cool itself down.
Okay, but what if the reason isn't about avoiding danger today, but about making the best of a bad situation from the distant past? Our next theory takes us billions of years back in time, and it suggests being green is just, well, a historical accident.
Now this is a wild idea. It's often called the purple Earth hypothesis, and it's exactly what it sounds like. The very first life to figure out how to eat sunlight didn't use green chlorophyll. Nope, it used a simpler pigment that made it look purple.
And as another Redditor put it so well, chlorophyll didn't evolve to be the absolute best system possible. It evolved to use the scraps, the leftovers. It was just good enough for the world it found itself in, and there's never been a big enough reason to upgrade the whole system.
The story this tells is just so cool. Picture it. Ancient oceans, totally dominated by these purple microbes, just soaking up all the rich green light. In the darker layers below, other microbes had to figure out a different way. They evolved this new system, chlorophyll, to capture the red and blue light that was being ignored. It was a system born out of scarcity that ironically turned out to be so good it eventually took over the entire planet.
All right, but what if the color has less to do with the light itself and more to do with all the other ingredients a plant needs to live?
This third theory says we have to remember that a plant is a whole factory, not just a solar panel. You can give a factory all the electricity in the world, but if it runs out of raw materials, the assembly line grinds to a halt. And for a plant, in most real-world situations, the biggest bottleneck isn't sunlight. It's the scarcity of carbon dioxide in the air. A plant can only build itself as fast as it can pull carbon atoms out of the atmosphere.
So when you actually look at all the things holding a plant back, as this chart shows, sunlight is often the least of its worries. If it's already waiting around for more CO2 or more water or key nutrients from the soil like nitrogen and phosphorus, there's just no reason, evolutionarily speaking, to develop a better system for absorbing even more light energy that it can't possibly use.
So the real reason plants are green is probably a little bit of all three theories, right? A mix of solar safety, a dash of ancient history, and the practical bottlenecks of chemistry. But here's the thing. All of these factors are tied to one specific variable, our sun. So what happens if you change the star?
Check out this graph. It shows the light from different kinds of stars. Our sun, that orange line at the top, has a huge peak right in the visible light we see every day. But most stars in our galaxy are actually cooler M-dwarfs, those reddish lines at the bottom, and they pump out almost all of their energy in the invisible infrared part of the spectrum.
And this leads to an absolutely incredible question. What color would life be on a world orbiting one of those M-dwarf stars? If the plants there evolved to absorb all that abundant infrared light, what colors would they reflect? Would their forests be blue Or maybe yellow? Or could they even be a color that our human eyes can't even perceive?
And that leaves us with one last big thought. The greenness of our world feels so fundamental, so final, but it might just be a local adaptation. It really makes you wonder if green is the universal color of life, or if it's just our own beautiful cosmic shade.